Memory management in Java is such an important topic for interviews and programming, but no one is going deep enough and covering everything. In this video, I'm going to cover Java memory management and garbage collector in depth, and has all the information which you need to crack literally any interview and make you a better programmer. It is a beginner friendly video, but by the end of this video, you will be an expert and can compete with experienced folks in the market. I just want your attention to stay by the end of this video, and it's free to learn. Just a like will help me know that you are a great learner. So without wasting any time, let's begin. Alright, so these are the topics that we are going to learn in this entire video series. The first one is the Java memory management. We will understand the overview, who manages the memory in Java and what actually is happening behind the scene. And then we will understand the stack memory, then we will understand the heap memory, and literally we are going to cover the entire architecture of the heap memory and everything which is going to be asked related to heap memory in the interview. Then we will cover garbage collector, and at the end, as a bonus, I'm going to cover important interview questions. Trust me, this interview questions I have collected from my own experience and from my advanced sources, and literally there will be nothing outside this interview questions that is gonna ask. So you just need to learn and understand and just memorize it, and boom, you will be an literally expert. All right, let's move ahead. Cool. So we will start with very basics and we will take it slow, alright? So just have patience and you will learn everything, okay? So first of all, what is Java memory management? It is as simple as Java memory management is the process of efficiently allocating and reclaiming memory during a Java application lifecycle. So it's a very simple concept. Why do you need memory management basically? Alright, because memory in our entire world is not free, right? It has certain limitation, like everyone has certain limited memory. It's not like the universe, that universe has an entire database of memory, but as a computer, every computer has limited memory. All right, so you have to use that memory very efficiently so that you don't run out of memory, right? And for that, the concept of memory management has come into the play, right? So in Java, let me tell you first of all who manages the memory. It's the JVM, Java Virtual Machine. This is the guy who is managing the memory in the Java everything. So whatever programming, whatever coding you will do, everything goes, because when you do certain programming, when you define a data, when you define a variable, when you define an object, everything requires a memory to be stored, right? And who will ensure that this is, storing it in an efficient way? Our JVM will decide that how it is getting stored, and it is getting stored in an efficient way. The second point, what you need to know before we start, where is the data getting stored? Where is our memory? So it is basically nothing but our RAM, random access memory. So the number one question, who is managing our memory? JVM is managing our memory. Number two question, where is the data getting stored? In the RAM. The data is getting stored in the RAM. Alright, cool. Let's move ahead and let's understand our structure of the memory. So basically you will know that our JVM model has two types of memory. So let's say we have a RAM over here. This is our RAM, okay? And inside this whole RAM, we have two types of memory defined. The first type of memory is called as stack memory, and the second type of memory is called as heap memory. Okay, cool. So for now, to start with, you just need to know that there are two types of memory inside RAM. One is called as stack memory and one is called as heap memory. What is stack memory? It basically stores all the method, all the local variables, and all the references to the objects. Okay, all right. And very important, which you need to know, that it is a thread based memory, and heap memory, it is a global memory. Don't worry if you don't understand what is meant by thread based memory or what is meant by global memory. I'm going to explain you everything in detail, but for now just gather the information that stack memory is a thread based memory. It stores all the local variables, all the references, alright, and all the method calls. Each thread has its own stack and it is automatically managed. So we all know that stack works on the LIFO structure. So this particular memory, stack memory, this also work on LIFO structure. And this is a temporary memory. Okay, this gets cleaned up when a method call ends. So this is getting cleaned up very frequently, but the heap memory is different. It stores all the Java object and it is shared across all the threads, right? I'm going to explain you what does it actually means. Okay, let's take a new page. Let's probably change the color. Okay, this looks cool. So basically, when I say I have a stack memory, the stack memory looks like this. 1, 2, 3, 4, and it goes on. So this is my stack memory. And the heap memory, it's a very big memory. Okay, and it's just one. Heap memory is just one. So now you understand one difference, that this stack memory, there can be multiple stacks. This is my stack number 1, this is my stack number 2, this is my stack number 3, this is my stack number 4, but heap memory can only be one inside a RAM, and this is my heap 1, H1. Alright, cool. This stack memory works on the LIFO principle, and this heap memory, it's as simple as that. It is going to be shared across all the threads, right? So probably, why do we have different stacks? We have different stack because we need to have one stack for one thread. So this stack 1 is probably allocated to my thread number 1. This stack 2 is probably allocated to my thread number 2. This stack 3 is allocated to my thread number 3. And this stack 4 is allocated to my thread number 4. But this thread 1, thread 2, thread 3, and thread 4, this all the threads will share the same heap memory. This will have an individual stack memory, but it will share the same heap memory. This is the major difference between the stack memory and heap memory. I'm going to explain you how stack memory works and how heap memory works. Alright, till now if you have any doubt, you can please write down in the comment section. I reply to every comment. Alright, cool. Now, when we say, let's come here once again, what does stack memory stores? The stack memory basically stores your local variables. It stores your local variable. Okay, it stores your object reference. It stores your object reference. It stores your frames or the function frames, or it calls as function frames. And what does this memory store? This memory stores all the objects. Alright, cool. First of all, we will understand what are frames and what are the function frames and why this is called as temporary memory and why this is called as long-term memory. This is called as temporary memory because once the data is inside it, after the scope is ended, the data will be pulled out also. The data is inside it. After the scope is ended, the data will be pulled out also. But in heap memory, data doesn't pull out that easily. We have to run a garbage collector that we will see later on when we are learning heap memory by the end of this video. So for this, to remove data from our heap memory, we need something called as garbage collector. But to remove data from stack memory, what do we need? We don't need anything. It is automatic. It is automatically working on LIFO principle. Okay, it goes in and it comes out once the scope is ended. Remember this word, scope is ended. I will explain you what is actually mean. So let's try to understand this with the help of this example. Okay, let's try some other color. This looks cool. Okay, so we have this class B. This is the most important part. I need your total attention in this. So first of all, I will have a class memory example. Okay, I have this instance variable, I have this method, I have another method. Okay, in this method you can see this method A is calling method B. Okay, right? And we have literally every example. It has a string, it has a object also, and now we will see which line is doing what and where it is getting stored. So let's first of all do our line number 1. Okay, what does line number 1 says? It says that we have a string. Okay, and the name of the string is instance variable, and the string is defined as instance variable. So what will happen? Let's create our two memories first of all. So we have our heap memory here, and this is our stack memory. Okay, I'm creating two types of memory, and we will push everything one by one. Okay, cool. So the first line which says that we have a string and the string is instance variable. So you all know that string always gets stored in heap memory, right? So it's basically whenever there are, let's say, two string, whenever I'm defining a string like this instance variable, this will be getting stored here. Okay, this will be getting stored in a block of memory here, and it says that this is my instance variable. Okay, the string, and right, this instance variable, this is pointing towards the heap. So we have something, we have a string, okay, which is getting pointed towards this instance variable, right? Cool. Now comes the important part, the public void method A. Now I told you something about called as frames. So every function is a frame. So this function is a frame, and what is the scope of this function? It starts here and it ends here. So as soon as the scope of this function is finished, the entire data will be removed from the stack. Okay, so first what do we have? We have a primitive variable, right? Int local variable equal to 10. So where will this be stored? This will be stored in stack. So this will be here. What is the name? Local var. The name of the variable is local var. So local var, this is stored over here, right? Let's move ahead. Next, what is the step? Now it is calling method B, right? You remember when will the scope end? Well, the scope will only end when we reach the closing bracket. Until now we haven't reached the closing bracket. Before reaching the closing bracket, we have encountered method B. So now we are inside method B. So again in method B, you see we have again a new string, okay, which is as hello, and you always know that string is always getting stored in a heap memory. So we have one more string called hello, and it is stored over here, right? Cool. Next we have defined an object. What is the name of object? The name of the object is dog, right? So what actually happens over here? This is the most interesting part. When you see dog is our object, but what we have done, we have created a new object. This new keyword is important. So as soon as we created a new object, this new object will be created over here, the dog, the capital letter dog, right? This new object will be created over here, but this small letter dog, which is the just a variable which is referencing the the object, the class, this variable is part of method B scope, so it will be stored over here. Before that, I was talking also about frame. So let's say this is the frame of my method A. Every method has one frame. So this was my frame of method A. Now we are inside method B. So now for method B there will be a new frame created, right? So there will be a new frame over here. Now this is my method B frame, right? And this dog, this will be created where? This will be created over here in method B. And what is happening? This dog is actually referencing to this dog, right? Because this dog is an entire object and this dog is just a reference to this object, right? So the object is always created in the heap memory and the reference is always stored in the stack memory. This is how it works. Now next, what is happening? Now we have encountered a closing bracket. So when the closing bracket is encountered, what has happened just now? We have just closed the frame of method B. So now the method B frame is closed. Okay, we have encountered an closing bracket. So the scope of B is finished. So what is the rule? The rule says as soon as the scope of any function is finished, the data will be pulled out in a LIFO manner. And as you can see, the scope of B is now finished. So now this data will be pulled out, because since this is at the top in a stack, this will be now pulled out side, right? Okay, and now we don't have this anymore. And since we don't have this anymore, this is also destroyed. This connection is also destroyed. Now there is no connection between this dog and this dog. So now this dog, no one is, let me erase this, no one is referencing this, now this is free. Now next, what will happen? As soon as this scope is finished, next we will encounter the finishing of the scope A, this one, right? So now this will also be pulled out. So let's pull this out. Okay, we will pull this out as well. This is also pulled out. So once both of them are pulled out, now what has happened just now? Our stack is now again empty. This stack is now again empty and we don't have anything inside the stack. So this is how entire thing for stack and heap work. Alright, cool. So now if we come ahead, now you will be able to have an overview of what is the difference between the stack memory and heap memory. Now you can understand this. What is the scope of stack memory? The scope of stack memory is just method level and it's just local. And what is the scope of heap memory? It's a global memory. It's for everyone. Everyone can share this heap memory. Why? Just the stack memory is faster because stack, always the LIFO principle is always faster, right? So that's why, and since it's a temporary memory, that's why it is the faster. So our RAM has a temporary memory and a permanent memory as well. So our temporary memory, the cache memory, is always faster and this is slower than the stack. What is the lifespan? That it is a temporary memory. So it's just the method scope is the lifespan and this has a longer. When the heap memory will be destroyed? Never. Only the data can be removed with the help of garbage collector, and that can be done. I will show you how it is done. This is smaller in size, obviously, and this is bigger in size. This is thread safe, yes, because every thread has its own individual memory, right? And this is not thread safe because every thread can access this memory, right? So for example, we have a heap memory and we have certain data over here. Okay, now thread 1 can access this data, thread 2 can access this data, thread 3 can access this data. So any thread can come and change the value, right? So it is not thread safe. But the stack memory, the thread 1 has its own stack memory. So thread 2 or thread 3 cannot come and change the stack memory of thread 1. So that's why it is called as thread safe, and this is not a thread safe memory, right? Cool. Now let's move ahead, and now we have come to our very important part, which is called as heap memory. What is heap memory and what does it do? And we will understand the entire architecture of the heap memory. So heap memory is basically, it stores all the Java objects. We just have seen that it stores all the Java object. It is shared across all the threads. We just have seen that it is shared across all the thread. Next, it is divided into, first of all, 3 parts. Okay, let me show you how heap memory looks like. So imagine this is our heap memory. Okay, first of all, this heap memory is divided into 2 parts. I'll come back to the 3 part later. First understand the first division, which is the 2 part. This part, one part is called as old generation. Old generation. And this part is called as, one part is called as new generation. New generation. Again, the new generation is divided into further 3 parts. The first part is Eden. This is called as Eden. Then we have S0, which is called as Survivor 0. Then we have S1, which is called as Survivor 1. So this is my entire heap memory, and the heap memory also contains one more part, which is called as the metadata, the meta part, metaspace. Okay, heap memory has one more part, which is a separate part, and this is called as meta space. Okay, so this is the entire heap memory. This is how it looks like. I will tell you what every part does and what objects goes in and how the garbage collector runs. But see, this is our young generation, this is our Eden space, this is our survivor space, S0 and S1, and we have our old generation as well. And then we have meta space. Initially, when Java was launched, it was called as premgen, and now it is called as meta space. It stores basically all the class metadata. I will tell you how it is getting stored. Cool. So first of all, now let's deep dive into how objects are getting created and how objects are getting destroyed and how the data is getting passed to different generations of the memory. Alright. So first of all, as soon as you create a new object, how do you create a new object? It's like dog obj is equal to new dog. So as soon as you create a new object, the object will come over here. Let's name the object as O1. Always remember, any object which is getting created, it will always be created in the new generation, and inside new generation also in the Eden space. In the Eden space, all the new objects are getting created. So let's say I created object 1, O1, O2 and O3. Okay, so this O1, O2, O3, this will be created in the Eden space, right? Cool. Okay, now we just have learned a few minutes before that there was a reference to this dog variable, right? If you remember, there's a reference to this dog variable, and as soon as the dog object was removed from the stack, this reference got cut. So once this reference got cut, now there is no one which is referencing this dog variable. So what will happen? Now garbage collector will come. So first of all, garbage collector will come and he will see that what are the objects which are not getting referenced by anyone. Okay, so he will see that, okay, dog, this is not getting referenced by anyone right now. Hello, this is not getting referenced by anyone. This is not getting referenced by anyone. So this we have to delete. Now our garbage collector has understood that we have to delete this objects. So what it will do? It uses mark and sweep algorithm. Mark and sweep algorithm. This algorithm is used by our garbage collector GC. So now GC will come and GC will mark the objects which are not currently used. So O1 it will mark, O2 it will mark, O3 it will mark. And after marking these objects, it will sweep, and it will sweep these objects to our survivor space, and it will sweep this object to our S0. So now O1 is here, O2 is here, O3 is here. Okay, and as soon as this is here, our hidden memory gets freed up. Now this is free. Alright. Oh, I need to make this once again. 1 second. Okay. Alright. And this is now free. So O1, O2, O3 come here. O1, O2, O3 come here, and this space got free, and now new objects can be created over here. But as soon as O1, O2, O3 come here, the garbage collector does, it defines an age along with this. So it will define age is equal to 1. It will define age is equal to 1. It will define age is equal to 1. So what is the age? All of this object has our age 1 because it is just getting swept. Alright, and now the user can create probably more objects, O4 and O5 over here. Right, now after some time O4 and O5 also get dereferenced, and now again garbage collector will come and again it will mark these objects, and now it will sweep the objects, right? So before sweeping, what it will do, after a while, probably after a while, all right, once one cycle is completed, these things will be moved to survivor space 2. This is my O1, this is my O2, and this is my O3. Now what will be the age of this space objects? Now the age of this object is 2. Age of this object is 2. Age of this object is 2. Okay. After here, now the compiler see that, okay, in some time, what is happening? This got dereferenced again, but this got referenced again. So now we have to save this and we have to delete this. So let's say we have a threshold limit of age is equal to 2. So once we have a threshold limit of age is equal to 2, this will now go into old generation. And here our O1 and O2 will survive for some time, for a while. It survives for a long basically, and then it will be deleted later on. So now we have to save O3, and O3 will again be moved to S0, right? And this hidden space, this garbage collector will come and it will remove this. Alright, so this is the entire working of heap memory. This is how it basically works. So it basically swaps the object from hidden to S0, then S0 it increases the age and go to S1, okay, and frees up it. So once the thing goes to S1, it frees up the entire S0, right? And then once it frees up the entire S1, the objects will come to S0. So always remember, now this is my O1 and O2, always remember one survivor space will always be free, okay, empty, alright, to move the objects, right? And everything contains an age. This is the entire working. Now if we talk about metaspace, what metaspace actually signifies, metaspace will tell you about the class. The class, it stores the class and it stores all the class meta data. It is as simple as that, right? Okay, cool. So I hope you have understood till here, and then we will understand a little bit more about the garbage collector, Java garbage collector. So garbage collector, it basically automatically free up the memory by removing unreachable objects, basically the dereferenced objects, dereferenced objects. What are the types of garbage collector? We have a serial GC, we have a parallel GC. Okay, don't need to go in detail for this. You just need to remember the name: serial GC, parallel GC, CMS GC, and G1 GC. Okay, G1 GC is default in Java 9 plus. It divides the heaps into regions and balances latency and throughput. So basically it helps us to improve our performance. Okay, this concurrent mark sweep, this is low latency need. This is multi-threaded and good for through high throughput apps. And this is CLGC, is the simplest garbage collector, which is good for our small apps. All right. Okay. Now at the end, let's talk about our few interview questions. Right. This is very important part, and this you need. I hope I have explained you all of this. We just go through this once and let's see what is there. So what is the difference between stack and heap memory in Java? This we have understood. The stack is for execution, store primitive and references, and heap stores the object and is shared across all the threads. The next question is, how does garbage collection work in Java? So you must have understood by now, the garbage collector identifies and removes objects with no active references, and it uses mark, sweep, or generational techniques. What triggers a full garbage collector? So system.gc. This is an important command that you should know. System.gc. So if you want to run the garbage collector manually, you can use this command. That ideally the garbage collector is run by JVM. Okay. And the JVM is the one who decided when should I run the garbage collector. But if you want to run it manually, that okay, I force the JVM to run it right now, you can use this command system.gc. But after this also, the JVM does not guarantee that if you use this command that it will run it. There's a high possibility that it will run it, but there can be a case if JVM feels that there is enough memory, it might not run it. Okay. So this thing is the important part which you should know for interviews as well. Can an object be garbage collected even if it's referenced? No, only unreachable objects, okay, are eligible. So if the object is referenced from somewhere from stack memory, it will not be deleted because there is a reference to it, and how can garbage collector delete it? Okay. What is memory leak? So memory leak is holding references to unused object, prevents garbage collector causing memory to fill up. Okay. So this is the very important question which as a tester also you might have seen, or you might have faced this in any interview. So it says that memory leak is something whenever there is an unused object, but still there's some reference which is holding the object, and that reference is also of no use, right? And it is unnecessarily using up our space. So for that reason, our memory leak can happen, and we don't need to have this in our code because it will destroy our performance. What is the difference between the minor and major GC? So we have already learned this. It's just the naming convention. Minor GC targets the young generation, and major GC target the old generation. Okay, so if you come here, this old generation, this is also called as major GC. Okay, major garbage collector. So major garbage collector will run on old generation, and the minor garbage collector will run on new generation, and that's it you all need to know. And Metaspace, we have already learned Metaspace. It stores the class metadata. Okay, heap resizing and permgen was fixed size and deprecated. Now Metaspace is the new name. All right, cool. So this was all for this video. If you have learned anything, just a like and a subscribe will help me to know that you have learned, and you can also drop in comment so that I can know that you are learning and give me a little motivation. Until then, I will see you in the next video. I'm going to come up with more interview questions and more interview topics. So for that, you need to subscribe. Until then, goodbye, bye bye, take care, see you.